Hey everyone, welcome back to the channel. And today I'm incredibly excited to share the research and a tool that is revolutionizing how AI systems are perceiving the knowledge that we're giving to them. If you've been following events in AI, you've probably already heard about RAG, Retrieval-Augmented Generation. Well, LightRAG will take this concept to a whole different level. And this is because for here, we're going to create knowledge graphs that will deliver the data to the LLM. This is kind of a fundamental rethinking of how AI can use information from now on. But before diving into LightRAG, let's talk again. What is RAG? Let's review that part. So RAG stands for Retrieval-Augmented Generation. It's a framework where large language models are connected to external data sources. Instead of relying on what was learned during the training, RAG systems can retrieve relevant information from databases, documents, or other sources, and then use that information to generate more accurate and precise responses. You can think of it as an ability of AI assistant to look things up before answering to you. And this is especially valuable for specialized knowledge, recent events, or anything beyond AI's training data. However, traditional RAGs have a lot of limitations. It typically retrieves information as flat pieces, chunks of text that have no connection between each other. So basically for a normal RAG, a naive RAG, it's very hard to find connections between different subjects or topics in one book, for example. And this is where LightRAG comes. So LightRAG enhances a traditional RAG by incorporating this knowledge base, which is consisted of graphs and is added to the retrieval process. Instead of just pulling relevant chunks of text, LightRAG will identify entities and their relationships, create a big knowledge graph between all these entities and their relationships, and capture all these interrelationships, interconnections between all the different entities. Here is why it matters. LightRAG will understand how different entities will relate to each other. So for example, in insurance text, it would mean that it can connect points between premiums, policies, claims, laws, which will give LLM a much better overview and understanding of how these things are connected. LightRAG employs low-level and high-level retrieval. So low-level focuses on specific entities and relationships, like answering to a query, what is deductible? While high-level will address broader topics and themes. For example, how do risk factors affect insurance pricing? LightRAG features an incremental update algorithm that integrates new information without reprocessing the whole entire knowledge base. And this keeps the system always updated in current rapid environments. By combining graphs with vector representations, LightRAG increases the accuracy and also the speed of the response, which makes it more cost-effective. So now let's break down how LightRAG actually works. First comes text indexing. So the system segments documents into manageable pieces, and this allows quick access to relevant information without having to look the entire document, right? Next comes the entity extraction, and here LightRAG takes a large language model and leverages it to identify people, organizations, concepts, and events, along with all the relationships between them. Now, for the graph generation, the system uses three key functions. It extracts entities, which are called nodes, and the relationships between these entities, which are called edges, from this text. It generates key value pairs for efficient retrieval, with the entity names as index key. It also performs the duplication, which means if there is two identical entities, it will merge them. And finally, for the answer generation, graph will combine these graph elements with large language model capabilities to produce this field, comprehensive, accurate answers. Again, what are the implications of LightRAG? By understanding the relationships between the entities, LightRAG can provide more comprehensive answers that take into account all the interdependencies between the entities, respond significantly faster, which will reduce the cost of deployment, adapt quickly to new information, and have efficient updating, understand complex dependencies that the flat text retrieval would miss. And finally, connect information between different documents that traditional RAG just cannot. In fields like finance, healthcare, legal, this could be a game changer because here the information can be really deeply connected. It's about understanding how all this information fits together in a complex web of relationships. And now I'm going to show you the GitHub repo, the paper, how do you use it, and I chose this time to use a document about non-life insurance because it's related to the field where I work in as an insurance mathematician, and how I generated from there the knowledge graphs. Let's do it. Okay, so first I'm going to share with you the GitHub repo. So this is a repo. It's called LightRAG. And let's go here. Here we can see there is a YouTube video about it. I think it's from prompt engineering website, prompt engineering channel, but I'm not sure. Let's check it out if it works today. Yeah, so this is a tutorial from prompt engineering channel. And I think I already once shared with you this channel. It's pretty good. It helps a lot to learn new things. Okay, so we also have a paper here, which explains all the things I explained today and a little bit more deeply. There's also some scoring about how LightRAG performs comparing to other, for example, GraphRag, and it performs pretty good comparing to GraphRag, although it is much more cost effective. Yeah, if you're interested or you want to go to more details, you should definitely read it. And it's also really easy to read it. It's very small and it is really a light reading. It was a good paper. Okay, so the page they have also shows a lot of different things about how to connect it to different kind of tools. But today I'm just going to show you a simple example about how to run this code and generate the graph rags with an OpenAI API. And we were going to do it through Visual Studio. So let's open Visual Studio. I already ran it, but I will do everything from the beginning so you can follow. Please let me know if you need me to share with you a video about how to install Visual Studio and how to install Python and all the basic things, because I don't really know what kind of audience you are, how technical you are. I think this video is pretty technical, so I assume here that you already know these things, but if you need it, I will be happy to do it. So with the assumptions I already have it, I will show you how we're going to start this. So we will open our folder on the desktop and I will just create a new folder. Let's call it test LightRAG. Create, open. And what I'm going to do is I'm going to clone my repository from here to my Visual Studio. Clone. So we put the link here. Yes, it is it. It asks me again. Sorry for that. Where is it? Here it is. Select as a repository destination. Open. Perfect. So we're there. And now let's make sure that we have our virtual environments on. One more thing. I really had some issues to running this code with the new versions of Python. So I'm going to run this code with the Python 3.10 because that's what worked for me. Maybe if I would take more time, and I probably will, I'll discover what are the issues. But for now, I'm going to just take this solution. So let's create a new virtual environment. And again, 3.10 is the one I take and install the requirements. Let's wait until it installs the packages. Okay, I think it did it. So yes, it's activated our virtual environment. So let's make sure to be in the correct directory. So we are in LightRAG directory. That is perfect. Now, let me just check if we're actually on desktop. Sorry. So let's take CT desktop. So let's take CT. What was our name to select it? Test LightRAG, I think. Yeah, exactly. And now we're gonna go to the directory of LightRAG. Perfect. And now, first things first, I will show you, they have a folder called examples. And in this folder, they actually already provide us all the different things, all the different codes to use to run for different cases. In our case, as we want to run the OpenAI through OpenAI API. this is the code that I will gonna need. Sorry, not this one here. Okay. And they have their own example with a book that they provide. I will use my own, so we'll make some changes here. So first of all, let's run this code. Let's see if this will work so smoothly. If not, it's also good to show you what to do if it doesn't. Okay, and now let's create a folder. I call it non-life because my document will be about non-life insurance. Again, if you have some topics in mind that you would like to use during the videos, let me know. As I'm working in insurance mathematics, that's the first thing that I thought about, but maybe you would like to take some other things. And if some other things interest you, just let me know in the comments and I will consider it for next time. So let's create the working directory, and we should already have here somewhere the file. No, it didn't appear, but maybe it appears later on. I hope we're in the right directory. Now run this code, and this is all to set up our LightRAG. Yes, perfect. Now we're gonna define. Okay. So here's our non-left folder generated. And here I'm going to take my book about non-life insurance that I already changed the text format. It was in a PDF. I'll just put it here. This is how it looks. So it's quite full of things. And I'll change this name to the name of that book. And just copy it like this. Okay. And now they give us the code for different types of query parameters. Let me show you what this exactly means. So in their GitHub, they talk about it. Here. So the local one focuses on context-dependent information. The global utilizes global knowledge. The hybrid combines local and global retrieval methods. The naive performs a basic search, and that's the most uninteresting. And I think the mix is the interesting one, which is integrates knowledge graph and vector retrieval. Mixed mode combines knowledge graphs and vector search. So uses both structured knowledge graphs and unstructured vector information, provides comprehensive answers by analyzing relationship and context, supports image content, and allows control over retrieval depths via top K parameters. I think we already talked on one of the videos about top K. I think it's called something with parameters. Yeah. And so let's take mix. I think it's the most interesting one. And let's erase all the others because they're really unnecessary. We're gonna perform a mix search. Okay, just delete. And here we put mix. No, there's no mixed. Good. Now, this is how we do it. One thing we forgot is our OpenAI API. How do we generate that one? We have to go to API website, create new secret key. Let's call it LightRAG. Okay. Select project default, create secret key. Please don't share this key to anyone. I will obviously delete this key after this video. I've seen a lot of cases, and it's quite funny and sad at the same time, where people go through YouTube's or different Google Cloud notebooks and just steal those API keys and use them. Just be careful. Okay, and now we want to set our variable for the OpenAI key. So we do it this way. Open and see if I do it correctly. Wait, I'm really serious. API key. Hopefully I'm right. Equals to, and then there's our to add the Okay, good. And let's run this code. Good. Wait, sorry for that. Now it should be fine. Now we have this and this. What else? Let's try and see if we have any mistakes. Okay, so we got our response generated, and I only realized now that I didn't change the question. So let's change that now. What are the top themes in this book? I think it is more precise. I mean, probably it already caught it in the correct format anyways. Yeah, actually it is. So I can summarize key themes, blah, blah, blah. It seems there is a misunderstanding since provided data are primarily related to non-life insurance topics and not a specific story. Exactly. So with next time, just be careful with that. Sorry for that. However, I can summarize key themes based on the information available in the knowledge graph and document chunks related to non-life insurance. And then it goes through key topics, type of non-life insurance, claims with coverage, underwriting and risk assessment, emerging products, legal rigor, and regulatory framework. Good. And what it did is also it generated here in our non-life folder all the entities, all the nodes, and all the relationships you can see here. So there's different people who are related to this document. There is also retroactive insurance, bad face claims, non-life perils, risk control, definition of risk control, and so on and so forth. Okay, so what do we do now? We will run a different code to see these graphs. And this code is called Python. Here it's given to us. HTML because Neo4j requires more installation, so we go the easy way. Graph, the visual, this HTML. Before that, I already see as we changed the folder name, I have to change it also here. And our folder was called something non-life, I think, but let me just check on that. Yeah, non-life. Non-life. Yeah, so let's save that. And now we can run our code. I think I made a mistake. Again, Python, graph, visual with HTML, Py. Sorry, we have to go to the examples folder. So ls cd examples, and now we run our code. Perfect. And now what this code did, it generated a file. Okay, and now I realized one more mistake of mine. The non-life folder should have been always in examples. If not, it won't work. So let's move it there and try again to run our code. Okay, and finally we have our knowledge graphs that we can run. Let's open it first in the folder, because if not, it will not run. So please open in Revealing Finder. Does it want? Okay, then, here it is already, right? I'm in the correct folder. Let's try it again. So we are in test LightRAG, examples, and somewhere here. Here it is. So let's open that. And here is our knowledge graph base. So let's look into it. What do we have here? We have non-life insurance, and you can see directly the definition of non-life insurance. It says non-life insurance covers risks that do not involve life insurance, typically related to property damage or liability. Non-life insurance covers various policies. What else? It's connected to risk management, reinsurance. And reinsurance is a risk management practice. So it also connects to natural disasters, pure risks, cell phones even. I didn't really read properly the documents, so I don't know why exactly, but for some reason it is. Wait, sorry for that. It's quite funny to use it. Then we can go more down, maybe these are people related to the book itself. What else do we have here? Some risk control activities, fire insurance, discrimination criteria, health insurance. So all the possible insurances and risks and programs and people connected between each other. I find this incredibly cool. Also here, for example, claims, and then we have around claims, motor insurance, claims made insurance, occurrence, insurance limits, insurance contracts, reporting, like economic losses. So this is really great. This is great because when the model will search for information, it will really, really link to all the possible aspects. And the coolest part is now we saw a very simple example, and I did not treat my data at all. So I did not pre-process it. I didn't clean it. It was just pure text. And I can actually do this for a lot of books and a lot of countries. So this was International Actuarial Association book, but we could take specifically Switzerland or specifically US, and it will just generate these graphs and help our large language model really understand things more deeply and connect them in a more meaningful way, which will make our jobs more easy, and we don't have to search for information and make the work of connecting things and searching different sources. We can see all the sources here and understand, true, there is a connection here. Of course, we know some connections ourselves, but sometimes we miss it, and this is why this is very cool. Okay, guys, so this is it for today. I hope you enjoyed this video and it was useful. Again, let me know if you need more bases or any other interesting topics that round around large language models, and I'll be happy to learn about them or talk about them and make a research on it. I hope you enjoyed it, and I see you next time. Bye.